Hi class, this video is over section 4.4 triangle congruence, side 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 and side angle side. This video will have two parts. The next part of the video will be over section 4.5. The learning target for today is that we will be able to determine whether triangles are congruent by the side 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 and side angle side postulates. First, we need to cover a few quick vocab words. An included angle is an angle between two sides. An included side is a side between two angles. Looking at this triangle, what is the included angle of side AB and side BC? So here we have side AB, here we have side BC. The angle between those two sides is angle B, so that's the included angle. What is the included side of angles A and C? Well, here we have angle A and angle C, so the included side would be the side in between, and that would be side AC. And then finally, what sides include angle A? Well, angle A is included in two sides, side AC and side AB. So AC and AB. Recall from the last video that congruent triangles have three pairs of congruent angles and three pairs of congruent sides. Do we want to show that all three pairs of angles are congruent and that all three pairs of sides are congruent every single time? The answer is no. That would be a lot of work to always show that all the sides and all the angles are congruent. So today we're going to learn the shortcuts for proving that triangles are congruent. First, we have these two pairs of triangles. You can see that all of the sides are marked congruent. BA is congruent to XY, AC is congruent to YZ, and BC is congruent to XZ. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. This is called the side, side, side postulate. We will always abbreviate this by using the letters SSS. So now I'm going to state that these two triangles are congruent. So triangle BAC is congruent to triangle XYZ. Remember that this is called a congruence statement. You always have to list the congruent parts corresponding. So angle B is congruent to angle X, angle A is congruent to angle Y, and angle C is congruent to angle Z. Make sure that you're listing the letters in the correct order. And the reason I know these two triangles are congruent is the side, side, side postulate. Now let's look at another way to show that triangles are congruent. On this triangle, we have side CB being congruent to side XD, angle B and angle Z, and AB and ZY are congruent. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So B and Z are the included angles because they're between the two congruent sides. This is going to be the side angle side postulate. We abbreviate it as SAS. See, whenever you're looking at the triangle, you have a side angle side and a side angle side on the other triangle. That's whenever you'll use the side angle side postulate. So let's go ahead and write a congruence statement for these two triangles. Triangle CAB is congruent to triangle XYZ. The reason why they're congruent is by using the side angle side postulate. So you can see that these methods are easier than proving all three angles and all three sides are congruent. Alright, so let's think some deep thoughts. You have two triangles, triangle ABC and triangle XYZ. We don't know if these two triangles are congruent because they're not marked congruent and we don't have any information about them right now. Let's say that I gave you this information right here. I said that A was congruent to X and B is congruent to Y and C is congruent to Z. Does this sound like any of our postulates that we've learned so far. Side, angle, side, 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 side. No, this is just dealing with angles. So this would be angle, 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 or AAA. Can you prove that the triangles are congruent? The answer is no. This is a huge no. If you ever just have angle, 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 you cannot prove that the triangles are congruent. Angle, angle, angle will never, ever, ever prove that. Alright, let's try another example. We have triangle ABC and triangle XYZ again. And I tell you that angle A and angle X are congruent, BC and YZ are congruent, and CA and ZX are congruent. Does this sound like any of our postulates? No. Here we have a side, side, then an angle, and here we have a side, side, then an angle. If you look at SSA spelled backwards, it spells a bad word. If it spells a bad word, then you cannot use it to prove that the triangles are congruent. So that's a really easy way to remember this one. So side, side, angle cannot prove that triangles are congruent. Are the triangles congruent by which postulate? So first example, we have LMN and QSR. Since we have 3 pairs of congruent corresponding sides, we can say these triangles are congruent by using the side, side, side postulate. Alright, the next one. We have a side congruent, we have an angle congruent, and we have another side congruent. These angles are included angles because they're between the 2 congruent sides. So this triangle has side, angle, side, and this triangle has side, angle, side. So yes, the triangles are congruent by side, angle, side. And then the final one. The answer to this one is no, because it's angle, 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 and angle, angle, angle never proves that triangles are congruent. Could you prove that the triangles are congruent, and which postulate would you use? Alright, on this one, we have these sides are congruent, this side and this side are congruent, and this side and this side are congruent. So since they have 3 pairs of corresponding congruent sides, we can say that they're congruent by side, side, side. The next one, we have a side congruent and we have another side congruent. We only have 2 pieces of information, and the theorems we learned today use 3 pieces of information. So sometimes you might have to mark something that you know is congruent but is not marked in the picture. Is there anything in this picture, an angle or anything like that, that you could mark congruent to the other triangle? Well, we can always mark vertical angles congruent. Vertical angles will always, always be congruent. So on this triangle we have side, side, angle, and over here we have side, angle, side. So this one we cannot use to prove these triangles are congruent. We have side, side, angle on this side, which you can't even use to prove the triangles are congruent. And then over here we have something completely different. We have a side, angle, side. What information do you need to prove that these triangles are congruent? So right now I have that AB is congruent to CD. I know that CB is congruent to itself. So both triangles have this side right here, which means that it's the same as itself. And then I have that AC is 8. So I need the side congruent to AC to have the same measure, and that would be this side over here. So we would need to know that DB was equal to 8 in order for us to have the side, side, side postulate. So the 7s were congruent, the 6 was congruent to itself, and we needed the 8s to be side, side, side. Or we could have marked these 2 angles right here congruent, and then we would have had side, angle, side, and side, angle, side. So let's see if you understand it. I'm going to show a picture, and then you need to decide whether or not the triangles are congruent and state the reason. I will not explain these, but I will give the answer. So here's the first one. Notice that I marked this side congruent to itself. Anytime you have two triangles sharing the same side, it will use the reflexive property, which says that something's equal to itself. So this side's going to be congruent to itself. So the answer is yes by the side, side, side postulate. Notice on this one you have parallel sides. Right now we only have that these two sides are congruent, and then the side going down the middle is congruent to itself. We can use these parallel lines to show that our alternate interior angles are congruent. So now we have a side, and an angle. We have a side, and an angle. So sadly, we cannot prove that these are congruent because side-side angle does not prove triangles congruent. And then the last one. Our third piece of information that's not marked is that the vertical angles are congruent. But this still will not allow us to prove these triangles are congruent because this would be angle, angle, angle. So I'm going to stop this video now. You will now need to watch the section 4.5 video that goes along with this 4.4 video. Both of the videos are over triangle congruence.